I'm Tatenda from NMMU. I'm going to be talking about my study, which I'm supposed to finish writing up now, submitting my thesis on the 5th of December. So I'm busy with my analysis, but I do have preliminary here. And I did a study on single tree water use and water use efficiencies of different species, indigenous versus exotics. So the race is going to start now. I didn't put it on the title slide. Great. So my outline, I'm going to do an introduction, give you a context or background of why are we looking at water use of forest trees in South Africa, what's the whole point. I'm also going to talk about the methods that I used, give you a little bit of my results and the discussion and the conclusion. And I think I'm going to start from my introduction now. We only have about 300,000 hectares of indigenous forest in South Africa. That is very small, 0.1%, 0.01 of the land. 1.25 plantations. We do a lot of plantation forestry, and these plantations are introduced species which were introduced mainly from Mexico and some eucalyptus from Australia, and they do use a lot of water. They've been introduced in the high rainfall regions of the country. If you look to your right, there's a map showing where plantations are mainly located. If you look to the bottom left, that's the map showing how much rainfall they get. And South Africa is basically water scarce, 425 millimeters per year. Average rainfall. So on seeing that plantation introduced species use a lot of water, there's been a lot of paired catchment experiments that have been done to show how much stream flow is being reduced by the plantations. And since the 1950s, we've done a lot of paired catchments. We've produced a lot of curves that show how much they reduce. And one of them is by Dr. David Scott, who's now lecturing here at UBC. I'm showing the Environmental Sciences Department or something like that. So we acknowledge that conventional forestry uses a lot of water, which is plantations in South Africa, but we abandoned indigenous forest way back in the 1900s when we saw that they grow very slowly, but we also have high value indigenous species. So we need to check out what if we can get, how much timber do we actually get from indigenous species if they do use less water like people proposed. So I looked at Ilex mitis, Ocotea bullata, Podocarpus, and Pinus radiata, which is the major exotic species in the Southern Cape region where I am studying. And Ilex mitis and Ocotea are indigenous species with high value timber in South Africa. I had 4 sites, and that's the map of Southern Africa, and the green dot is showing where my study area was, and that shows the weather station. HPV 3 and 4 is where the indigenous species sites were. HPV 1 and 2 is where Pinus radiata sites were. So I used the heat pulse velocity method. Indigenous tree specimens was based on finding desired species in close proximity because of the setup, and all specimens were supposed to be actively growing. Pinus radiata trees were 13-year-olds, and we used diameter to sort of like want to classify them in the same range. And that's the heat pulse velocity method. That's me in the field. It's basically measured separate in the xylem tissue based on heat conduction and convection. The ratio of the temperature change at the points equidistant after the release of the heat pulse in conjunction with the thermal diffusivity of the particular wood species can be related to set velocity, which we can then use to quantify cubic centimeters per hour using the cross-sectional area of the tree. And this is the method. That's what happens. That's the sap going up, the heater goes, the rate of change of temperature between the two prods, and then we can use that equation to get sap velocity, and the slide is consists of an Australian researcher. So that's my weather station, that's the velocity, and that's one of my study sites in the indigenous forest, Afro-temperate forest mainly, and I collected hourly weather data, rainfall, relative humidity, solar radiation, wind, and a whole lot of others that are calculated from the automatic weather station. And I did have challenges. It's in an indigenous forest. You get to a site and it's fallen. It's difficult work to come put it back up. And we did realize very high velocities in the Pinus radiata trees, and that correlated so much with the soil water. So the Pinus radiata trees get, as soon as it rains, the next hour they start taking up the water. And the other thing is I'm trying to model how much does weather variables affect the rate at which sap goes up in the tree. And we got very good correlations in pine, and I'm sure we also got very good correlations in indigenous. I'm just going to show you that next. And yeah, this is so yeah, okay, great. So this is some of the results that I got. Monthly transpiration. This is now Ocotea bullata with rainfall. versus the actual amount of water that was used. So for indigenous species, it was way lower. I would say maybe 60% lower than what Pinus radiata uses. But the efficiency, Pinus radiata is not as efficient in the Southern Cape because we've got soils that are not as good. If you remember the pictures, these are orthic A soils. They do not have enough nutrients and they're deep clay. So the highest efficient in my study, which is weird, is Podocarpus latifolius, 2.997 grams per liter, which is something that's like groundbreaking, and I think I'm going to be following up for that on that exponential result for a PhD. I'm not sure yet. And yeah, we had 935 millimeters of rain, which is quite high. We usually get like 700, so it was a different year. So we might be thinking that it's different. And that's just one of the models. Very varied data. I'm still trying to normalize the data and get it back to get a proper model and trying to remove some of the stuff that's just shouting at that. And yeah, we're getting good correlations with actual sap flow and weather variables. And one of the things that I think might have caused the Podocarpus latifolius to be very efficient is because we also have the gap dynamic system, like the other lady was saying yesterday, that when a big giant falls and then there's sunlight, that's how the Afro-temperate subcanopy species just start going high up into the tree. So yeah, we're just speculating that that's one of the reasons, but it is definitely an area for us to sort of like keep going on and see if we could actually get good timber and use less water in a water-scarce country like South Africa. So this avails much potential for the Southern Cape indigenous forestry industry. In the Southern Cape, this is the largest band in South Africa where we actually have these 300,000 hectares of indigenous forest, and there is so much scope to sort of like develop this. And I'm sure that should be my last slide. And yeah, however, we need to still develop robust process-based models for tree water use, for example, relating soil moisture regimes to the climate, before we can just jump in and say, let's go and plant yellowwoods like we did with planting Pinus radiata 100 years ago in a water-scarce Southern Cape region. We do have areas like KwaZulu-Natal. If you know the South African map, it's to the east, yes, Ulrich, east, right, east of the country. And there we have quite a lot of rainfall, good soils, and the Pinus species and the eucalyptus species do so well. So this is an aerial picture of our campus, well forested as well, and thank you.